Alright, so today I'm going to be showing how the addition or the deletion of one base pair results in the creation of a non-functional mutant protein using this protein. Alright, so first thing that I like to do is I like to write out all of the proteins, and then I like to write out under them the coding, like the codon that would go with it. And then after that, I'm going to take a look at all the codons and try to figure out if it's a addition or a deletion. Because if it's a deletion, everything is going to move back one, and if it's an addition, everything is going to move forward one. I look at these two right here, they're the exact same, and there's only one way to get them, so that's not what I need to look at. I need to look at this one. And as I can see, the only way to get from PHE to ILE is to add an A, which means I'm not deleting, I'm adding, so everything is going to be moved forward one. So now I'm going to look at the codons of this right here, and I'm going to compare the last two with the first two here, and I see that the first two here, 2 U's, and the only way that this matches with this is if it's with this one. So that's going to be the coding for ILE. Now I'm going to take the last one of this one and move that forward here. And so now I can figure out what this one is, because in order to get HIS, I need a C, and the only thing with the C here is UUC. So that's the coding for that. I can cross them off as I go along. Now I'm going to compare the first two of THR with the last two of HIS, and the only way to get HIS from THR is going to have an AC in the last two, which means that this has to be the coding for IHS. Now I'm going to compare the last one of THR to the first one of the stop codon, and the only thing that I can have beforehand in order to get the stop codon is ACU. Now I'm going to look at the first two of LYS and compare it to the last two of the stop, and the only thing that I could get for the stop codon would be UAA. This means I can write out my mutant and my normal RNA. AUG-UGG-AUU-CAC and UAA. As for the normal one, it's going to begin with AUG, UGG, UUC, ACU, and then it can be any one of these, since I don't have the codons after this stop sequence. I'm unable to determine what these guys are, but it can be any combination of these going forward from there. And then obviously this keeps going until it hits a stop codon. And what this has done is it has caused a nonsense mutation with the addition, meaning that the stop codon was created where it wasn't supposed to be created, which has caused the protein to become significantly shorter than the non-mutated protein.